Dear students, in this lecture we are going to see the working principle of K nearest neighbor classifier. Before going into the working principle, just we will refresh the things whatever we studied earlier. All the real world machine learning problems generally fall into any one of the three main category algorithms. Either the problem will be solved with the regression, or it can be solved with the classification, or it can be solved with the clustering. The first two categories are grouped into under the supervised learning algorithm, and the last category is classified under the unsupervised learning algorithm. This will refresh what is supervised learning. Supervised learning algorithm learns from a labeled set of training data. The inputs are given with the labeled data. The model is allowed to train from the given input data. So here the images are having two types of inputs. One is a Tom image, another one is the Jerry image. So based on the features extracted from the input image, the model is trained. If an unknown image is given to the model can able to identify the features available in the input image, and it will classify the image into either a class of Jerry or into the class of Tom. So supervised algorithms mainly work based on the label set of training data. Under the supervised learning, we have several algorithms: logistic regression, KNN, decision tree, SVM, random forest. These algorithms comes under classification. Linear regression algorithm comes under regression. We have already studied linear regression and logistic regression. In this lecture, we will study the working principle of KNN algorithm, because this algorithm is a very simple classification algorithm as compared to the other classification algorithm in the supervised learning. What is a KNN nearest neighbor algorithm? It is a simple, easy to implement supervised machine learning algorithm. This algorithm is mainly used for the classification purpose and regression purpose. Mostly it will be used in the classification application. This algorithm possesses two properties. The first one is it is a lazy learning algorithm. This algorithm does not learn from the training phase. Instead of that, this algorithm trained to memorize the training data. Next property is a non-parametric learning algorithm. The algorithm does not make any assumptions about the available training data. KNN classifier classifies the unlabeled data into a target class depending upon the features extracted from the neighboring objects. The features represent the similar informations belong to the nearest neighbor objects. Here the model is trained with two input images. One is of cat image, one is of dog image. The cat having the features of short ear and long tail. The dog have the feature of long ears and the short tail. So based on these features, the model is trained. Now an unknown image is given to an input model. So the model will extract the features and find out the similarity. Here the input image given have a short ear and the long tail. So based on the similarity features, the unlabeled data is now grouped into a class of cat category. So KNN assumes similar things are near to each other. Hence, the similar objects are classified into same class. There are variety of applications available for the KNN classifier. One of the application is in the financial sector. So based on the user data given to the model and the model is trained, the model can able to classify whether the user can get a credit amount or not, or whether the loan can be approved to the customer or not. In healthcare application, mainly we have something called as computer aided detection and diagnosis. If the medical image is given to the model is already trained with the variety of medical images, so the model can able to detect or classify whether that input image have a tumor or not. In political sciences, the opinion of the voters are already gathered, and based on that the model is trained, and now the model can able to classify whether the person will vote or not. In handwriting recognition, the texts are written by the user and the model can able to recognize the particular characters available in the handwriting. In image recognition application, the model is trained with set of images and its label. So if the image is given to the model can able to identify whether it belongs to the cat category or dog category or not with the other category. The other applications are video recognition, pattern recognition and so on. So here one of the problem statement is given. Study a bank credit data set and make a decision about whether to approve the loan of an applicant based on his profile. So here's problem can be solved with the concept of classification problem, because we have to decide whether we have to approve the loan or not. So here the KNN model is trained with the input bank credit data set. So once it is trained based on the unlabeled data, the model can able to classify whether you can approve a loan to a customer or reject a loan to a customer. And now the important thing, what does K in KNN represents? The K is nothing but the number of nearest neighbors. So consider one problem, and here we have a green point, data point, which is an unlabeled data. So around that we have several labeled data points. We have 6 blue data points which belongs to class A, and then 5 red points which belong to class B. And now we have to identify whether this green color belongs to which class, whether it belongs to class blue or class red. The problem statement here is the unlabeled data point belongs to which class. So that is our problem which is to be solved. And how will you decide the neighbors in the KNN? Generally, KNN works based on the feature similarity. So we have to identify the similar neighbor points around the unlabeled data. How to compute the similarity? The similarity is computed by calculating the distance between the unlabeled data point and the labeled data points. In order to calculate the distance, there are several distance metrics are there. Euclidean metric, Manhattan matrix, but Euclidean distance matrix is the most popular and familiar choice used in the KNN algorithm. This is the formula for the Euclidean distance, root of sigma xi minus yi the whole square. Suppose we have point P1 and point P2. We want to estimate the distance between the 2 points. P1 is represented with 1, 1, P2 is represented with 5, 4. Now we apply the Euclidean distance formula. So it will calculate root of x minus y the whole square plus x1 minus x2 the whole square. So that value you will get as 5. Like that we have to calculate the distance between the unlabeled data points to the labeled data points. Now we will see the procedure to find the class of the unlabeled data. So we have to, the first step is we have to initialize the value of k to an positive integer. For assumption, now I have assumed the value of k equal to 3. So for the unlabeled data green color, we have to identify what class this unlabeled data belongs to, whether it is class A of blue color or class B of red color. In order to do that, the first step is initializing the value of k to a positive integer. So here we are going to take k equal to 3. So the number of neighbors decided is 3. The step 2, we have to compute the distance between the unlabeled data to all the labeled data. So distance computation is nothing but we have to calculate the distance based on the Euclidean distance. So the Euclidean distance between the labeled data point and the unlabeled data point. Once it is done, the third step is sort all these distances in an ascending order. So once it is sorted, we are going to the next step. The next step, we have to select the first 3 labeled data points which is closest to the unlabeled data point. So after doing that, the next step is finding that labeled data points. So that three labeled data points are the nearest neighbor to the unlabeled data point. In the next step, we have to do counting the number of data points in the nearest neighbor. How many belongs to class A, how many belongs to class B. The class A is blue color, so here the number of neighbors closest to the unlabeled data, the blue color is 1. The number of neighbors of red color closest to the unlabeled data is 2. The last step of this algorithm is doing the majority voting. So based on the number of points in class A, based on the number of data points in class B, so class A having only one blue color, class B having two red color. So now based on the majority voting, the unlabeled data is grouped under the class of or classified under the class of red color, that is class B. So it is telling finally the data belongs to the class B, that is red color. So now the algorithm is summarized as below. First we have to load the data. The next step, we have to split the data into two-part, training data set, testing data set, because it is a supervised learning. So the model has to be trained with the training data and it has to be tested with the testing data set. In the training data set, we contain two informations. One is the input data, that is the independent variable, and along with that we have a label data correspond to each input data. And now we have to assume how many number of classes we need to classify. So generally it will be represented with C. The basic is C should be greater than or equal to 2. The third step, now we have a data point which is from the test data set whose label is unknown. So we have to find out what is the label of X. So we have to follow the procedure what we have already did. The procedure to find the label of X. The first step, initialize the value of K to a positive integer. The next step, compute the distance between the unlabeled data point to all the labeled data point. The third step, sort all the calculated distances in the ascending order. The fourth step, get the top K rows from the sorted array which is very closest to the unlabeled data. The fifth step is find the K points which is closest to the unlabeled data point. The sixth step is count how many points belong to class A, how many points belong to class B, and the last step is do a majority voting. So based on that the unlabeled data will be classified to the class which have a majority voting. Now how to select K in the KNN. So here we have to find out what is the class of this unlabeled data. So in order to do that, in the first step, the KNN algorithm consider K neighbors which is closest to the unlabeled data, that is the new data point, and decide whether the class of the new data point based on the majority voting. And here while we consider three neighbors, two neighbors are class A and one neighbor belong to class B. So based on the majority voting, the unlabeled data will be now grouped to the or classified to the class of orange, because orange is the maximum with three neighbors. So when we consider that three neighbors, the unlabeled data having the majority color is orange. So now the unlabeled data is grouped into the class of class A. Now we consider with K equal to 7 neighbors. So when we consider K equal to 7 neighbors, here 4 neighbors belongs to class B, that is green color, and 3 neighbors belong to class A, that is orange color. So based on the majority voting, green is the maximum among the 7 neighbors. So the unlabeled data is classified under the class of class B. So now we have a question, how to choose the value of K, because when you choose K equal to 3, the data is classified into class A. When you choose K equal to 7, the data is classified into class B. So now we have a question, what is the label, actual label for this unlabeled data, whether it is green color or orange color, because when you change the value of K, the class label of that unlabeled data also changing. So here the solution or the answer is, there is no rule or formula to derive the value of K. One value of K may work for one type of data, but it may fail for other type of data. So only we can do or select the K value by using the experimental procedures. And now we have some inferences from the KNN algorithm. So increasing the number of nearest neighbors may increase the accuracy, and algorithm may significantly slower when the volume of data may increase. The best choice of K depends upon the data, because for some K it will work for some data, for other K it will work for other type of data. But the general thing, large values of K reduces the effect of noise in the classification. So how will you select a good K? It can be selected by various heuristic or experimental techniques. There we can have a simple analogy for KNN. So KNN generally work with the neighbors. So we have an analogy that tell me about your friends so that I will tell you who you are. Thank you for listening.